All right, welcome to another episode of the Scripting Then podcast. Today I have an awesome guest. He's a Docker captain. He is the creator of the Docker Mastery course, and well, he's actually a lot of other things. Welcome, please, Bret Fisher. Bret, welcome to the show. Please introduce yourself and tell our listeners who you are and what you do.
Hello, I'm glad to be here. Thanks for inviting me. Yeah, I make things on the internet, so lots of content.
That's a nice summary, yeah.
I've been an IT professional for almost 30 years. I'm a graybeard now, and I have a YouTube channel, podcast, newsletter. I make courses. I do online and real life training. I speak at conferences. So I'm all in on the container bandwagon. So DevOps and containers are sort of a match made in heaven. So this is kind of a great topic.
Amazing. Awesome. And that's perfect because I'm essentially DevOps or as I like to say, Docker stupid. And every time that word comes up, either on a conversation or just me reading something, my brain shuts off. And I wanted to have someone in the show to talk about DevOps, to talk about the concept of DevOps, and to talk about the tools of the shop and kind of clear the air on what is what, and if developers are interested in the topic, where they can go to learn more. So let's start at the beginning. Let's start by defining what DevOps is, because you and I were just having a conversation pre-show, and you were actually giving me a lot of information that I just wasn't aware of. So let's start there. Tell me what is DevOps and where the confusion is.
Yeah, well, DevOps it's at least 15 years old now. I think somewhere in the 2007-2009 timeframe was when the DevOps term was coined. But it came out of this frustration in the 2000s. And remember, this was a time where virtual machines were fairly new. We had virtual machines for less than a decade. And AWS Cloud, which was the kind of first public cloud, they had only been out a few years. So we had started to see all this expansion. The data centers were growing. We were all thinking that the cloud was the future. We didn't even know what hybrid was yet. That was not a term. Hybrid cloud was not a thing. So we kind of were thinking, we just knew that there was growth. We had servers everywhere. And for those of us that ran data center ops and were sysadmins or operations, and that's where I kind of came from, we were kind of on the other side of a wall, physically sometimes, but also virtually, a wall between us and the developers. Right. And if you go back to that time, before we even had the term DevOps or DevOps engineer, nobody knew what it was. You had teams of developers and you had teams of operators. I was on the operator side, and I always, even before we had the term, my goal really on the teams I was working with was always to be the best friends to developers and always trying to figure out how to work better with them. And it turned out that was really some of the core of what became the DevOps movement, which is really about culture and processes and business. It's not so much about tools, even though that's all we talk about today. Yeah. We're definitely going to get into containers. But when DevOps was coined, it was a series of frustrations around the dynamics of dev and ops. So imagine a story. There's a great book that tells this story, actually. It's I'm trying to think of the name of it, The Phoenix Project, which came out in 2013. It's actually if you're traditional operations or sysadmin, and maybe even if you're a developer, the book is hard to read because it's a fictional story. Okay. And it almost gives you flashbacks of bad projects that you've been on, because it's a fictional story of a guy that's put into a position of impossible odds where the company's tightening the budget at the same time that developers want to speed up the number of times they deploy, while at the same time operations wants to increase reliability. And thus the tension builds because you can't meet all these objectives all at the same time.
Yeah, I can see that.
And in the traditional world, as a developer like yourself or anyone else who's just involved with putting software on servers, we had these competing goals. Developers inherently want to ship as fast and as frequently as they can, and operations inherently wants to keep things as stable and consistent as they can. And that created a huge rift over the 90s and 2000s where we would talk about developers throwing their code. This is not literally what would happen, but they would throw their code over the wall to the operations and say, just make it work.
Right,
and operations would then test it and QA it and try to deploy it and say, nope, it doesn't really work well, try again. And so this created natural tension. It didn't probably turn into a lot of fist fights, but there were definitely a lot of verbal fights and a lot of verbal tough discussions. Yeah. So the idea for DevOps really started to come out around the idea that these two teams should figure out ways to work together and that we actually share the same goals. We just need to understand each other's problems better, which really just inherently comes down to change the culture to be more cooperative, less combative.
Right.
Make sure that the goals for performance reviews or goals for business objectives align with both groups and don't put them at odds with each other, right? Don't go to operations and be mad that the thing went down because developers pushed it through and rushed it to deployment for production because they were on a deadline, right? So these things inherently happen. And so the DevOps movement was more about how do we create processes and culture so that we're not blaming each other, that we get rid of the blame game, that we create what are now almost normal day-to-day processes. This is before we had Git, GitHub, Gitflow. This kind of came out of the agile software development movement where that cooperation was already starting to happen a little bit more with project managers and developers, but it wasn't really happening between developers and operations. As a side note to that, what was happening at the same time, where we were starting to get a lot of good tools in the operation space for creating infrastructure dynamically, kind of like software developers create their software dynamically. It used to take months, weeks, if not months, to deploy a server. You had to order it, you had to rack it, you had to physically set it up. We didn't even have virtual machines until around 2004. And so every time a new project was happening and developers wanted to deploy something, the operations needed months to plan in advance. We had to plan for cooling and power and backups and security and monitoring and you name it. We had all these different things. And then virtual machines showed up, but we didn't really have any tools to automate, to stabilize, and to create consistent environments for the developers. So in those early years, we were just, we were all like reading Word documents, trying to set up servers and manually and like type in commands that we were just reading off a document. And this challenge was that developers were starting to update software and want to deploy software faster than operations could handle because we just didn't have the tools for it. And that spun up this whole evolution of, we had Chef and we had Puppet, and then eventually we had Ansible and Terraform. And a lot of these tools are very commonplace nowadays, but back then when DevOps was created, it was the idea that agile infrastructure was a brand new concept, and the idea that we could maybe automate and make consistent our deployments as well as the infrastructure so that we could guarantee consistency between the developers and what they were testing on or building on versus what we were doing in the real world in production. And that was a brand new concept. Before that, it was really, really hard to guarantee consistency, if not impossible. Anyway, so that's the beginning. That's where it all got started. Notice I didn't say anything about like Jira, or not Jira, but Jenkins or CI/CD or containers, because none of that really
existed,
played into how we were trying the idea, how we were sort of floating the idea of what if we could make the infrastructure as nimble, agile, and as hard code or codified, I guess is the right word, codified, as we do the software that we're actually writing.
Right.
And that's where the beginning started.
So that means infrastructure as code came up before containers, before all Docker and all that movement.
Yes,
I thought it was the other way
infrastructure
around.
as code. No, absolutely. Infrastructure as code is not a new thing. It was coming out around the time of this DevOps movement because we had the dawn of tools like Chef and Puppet, which arguably aren't as popular anymore because they've sort of had their day where they were designed almost pre-cloud before we even had remote machines that we could instantly spin up. And then they sort of allowed the way for more modern approaches like Terraform and Ansible. Again, all these tools really do is automate the setup and tear down of infrastructure, which Before that, all we really had was shell scripts.
Right,
Or
yeah.
if you're on the Windows side, you had PowerShell and batch scripts. And those were very, very hard to maintain, especially when your infrastructure grew. And there was an inflection point somewhere around 2009. There was a famous talk that Flickr did. That's the image hosting company that's still around, but was much more popular back then, I think. And Flickr came to Velocity, which is a conference, again, that doesn't actually exist anymore. But O'Reilly made this great conference series called Velocity for many, many years. And at Velocity, they did this talk that was something like 10 deployments a day, how dev and ops can work together for, improving the software. And when that talk came out, people were like, companies weren't even deploying 10 times a year, much less 10 times a day.
Yeah,
It was insane.
Yeah.
Yeah, because if you... it's not just that you would have to have the software built 10 times a day, but you'd have to have potentially new infrastructure 10 times a day because like the software might change the infrastructure requirements. And you just sort of spiral out of control of like, well, how do we back that up? What do we have to restore that? How do we recover from failure?
Yep.
All these things, the idea is in most companies, that was a 6-month plan for one release.
Right.
And so they were proposing that if you set up the right software and the right automation, that your ops and devs could work together to increase the velocity at the same time increasing stability, which previously we didn't really all agree was possible. Because one was inherently, originally was the idea was like, if you want to increase velocity of deployments, we're going to be less stable. So you can't have both. You have to choose. And they were proposing, no, actually... You can have both. You just have to do it thoughtfully, and
Right. Interesting. And in where do then containers come into place? Because again, stupid here. So, to me, if you say DevOps, I go straight to Docker. So, run me down the process of how the containers came to be, and in that timeline that you were mentioning.
Right. And to be fair, like this is my passion is containers. Right? I've been talking nonstop about containers for almost a decade. So containers arrived, half a decade after the DevOps phrase was well known. Especially, it was well known, I would say, in the leading edge shops, right? And the ones that were going to O'Reilly velocities and we're testing out AWS in its first 3 or 4 years, right? So those were the leading edge shops, the Netflixes, the Googles, like these are the kind of companies that were doing that. So you fast forward 2014, 2013, the Docker project came out of this, and what had previously started to happen was when the idea of agile infrastructure took place and it started to permeate throughout the conferences and throughout books, we started to get new books. Accelerate was a book. The DevOps Handbook was a book. Actually, it didn't come out till 2016, but we started to see more of these books around the idea that infrastructure needs to be codified and it needs to be agile enough that we can change it without a bunch of fuss, without a big, giant project just to change infrastructure. And so the big shops, the really savvy people, like the ones I just mentioned, Facebooks and the Microsofts and all these companies, they started to toy around with features coming out of Linux that we now call this containers, but the idea of containers had existed since the 90s. Solaris had zones, FreeBSD had jails, Linux had chroot, and all these different tools or methodologies in the kernels of these systems were really about taking a piece of software, partitioning it off in a part of the operating system where it couldn't see the rest of the operating system, and essentially it looked like it was the root, hence the chroot command, and it took a lot of other additional commands to make it all work. You might have the files in a place, and then you would do these mount point things, and then you would need to create a virtual Ethernet interface, and then you would need to create IP table rules to section all this stuff off, and you basically had to be a super Linux guru. And so these teams at these big companies were doing all this and creating their own internal platforms for sectioning off code rather than using full virtual machines. And Docker was actually previously, before they were called Docker, they were a cloud hosting company that was trying to compete with some of the other cloud providers out there at the time, like Heroku. And they had their own internal mechanisms for partitioning off these different apps that would all run without having access to each other,
Right.
where they were isolated and protected, without you needing to create actual virtual machines for every single app, which is what me and my friends were all doing because we weren't the Linux gurus that the Netflixes were, right? So we were out there creating VMs and handing them off to developers and say, okay, you run your one.NET app on this virtual machine, and you over here run your Python app on this virtual machine, and this SQL team over here is going to run on these two servers. And the idea was we were creating virtual machines as the deployment artifact, right? So the entire virtual machine was what we deployed into the data center with the app on it. And it was very heavyweight, and it was huge. It was tens of gigabytes. And it was slow. I mean, it took a while to deploy that. It took a while to recover from that in terms of failure.
Yep.
You had to back up the whole VM every single hour. It was just a lot of work. So the big companies were saying, hey, look, the Linux kernel is getting these new features. Let's start using them. At the same time, the Docker team, previously .cloud, were using this internally for deploying their own cloud infrastructure. And they realized, well, I wonder if we just open source this part of our infrastructure, because a lot of our customers are just asking us how we do this.
Right.
So they created a project. They called it Docker, released it at PyCon, and it was like a 7-minute demo. In fact, Solomon Hykes, the creator of it, actually got cut off at the end of his demo because he was running over his 7 minutes in a lightning talk. And then fame was made, right? Like that was the moment when the world saw Docker. And within a year, I had heard about it, tried it, didn't understand it, gave up on it.
Okay.
Came back 6 months later, tried it again with a little bit better understanding, realized that, oh, it's not creating an entire Linux OS. It's just my app and its dependencies, not including drivers, not including the kernel. It's just the files on a Linux file system, but in an isolated area. That's all it is. And I finally, it kind of stuck with me. And for the first time in my career, I realized this, like the cloud and like virtual machines before it, is a game changer. And it will take us a decade to implement this game changer. And I want to be a part of it instead of being sort of like on the sidelines watching it all happen. And and so when you've been around long enough, you start to see trends. Like in the 90s, we moved from monoliths, or not necessarily the software, but the infrastructure, which was mainframes, to distributed computing. So we all started getting PCs. The servers were PCs. We were no longer running these giant multi-million-dollar mainframes and mini-frames and HP Unixes and all these things that I was doing. And so we distributed it out to a bunch of PCs, and then we realized, oh, we have no way to utilize all this infrastructure we bought, hence virtual machines. So virtual machines came out to better utilize our hardware, and then that led to the cloud, and then that led to we need to use the cloud more efficiently as well as our own infrastructure, and we're still deploying virtual machines as the artifact. And Docker came out and said, hey, let's not make the virtual machine the artifact. Let's just take your code. If it's a Python app, then it requires Python and Python libraries, so let's ship those with it, all the dependencies, and let's put that anywhere you want to run it as long as it has a Linux kernel. And so you can run that thing locally with the exact same binaries, the exact same libraries, the exact same Python code, bit for bit. I can run that locally on Linux, or I can run it on a server in the cloud on Linux, or I can run it in a data center on Linux, but it runs exactly the same way. There's no tiny differences in the DLLs, or that's in Windows, but on the libraries, just because I'm running over here Red Hat and run over there CentOS, or running over here on Ubuntu. And that was all happening in the real world in the data centers. But Docker said, here's a different way. If we isolate it, and then it wasn't enough for them to say, let's just isolate this and create something called the container. They did three main things. They created a universal builder that would build up your app in all of its code and all of its dependencies into something called an image. We all know that today is just Docker build.
Right.
Underneath that's called BuildKit now, but that was one of the three major inventions they had. The next innovation or intervention was we need to be able to distribute this. So they take that single artifact, that image, now that you've built it, presumably you've tested it, and you can now store that and transport it to any other Linux machine via a common HTTPS transport mechanism, essentially just using a fancy S3 on the back end to store this. So like any web server with this Docker registry thing on it could now automatically store all these images, distribute them, and HTTPS was becoming a very standard protocol back then in 2013, 2014. So that was a very common way to move it around, and it was great because it worked on any distribution, on any machine that ran Linux, or you could somehow get Linux on it. And the final ingredient was the consistency of the run environment. So no matter what platform you're on, you can type docker run, and it will run the exact same code regardless of which libraries were on the host. It didn't matter. Everything's just going to be in this isolated little environment. It's going to run the same way. So those three parts of it, had Docker not done the three of them, and maybe they just standardized on one of the three, or if they didn't really consider the whole picture, I don't think we'd know what Docker was today. It would have just been another little utility that nerds used at tech companies, right? Yeah. But because they created this 1, 2, 3 set of innovations, and they didn't require you to change any of your code, which I think was the real secret to it.
Yes.
Right?
Yeah.
So many other ways. We had Cloud Foundry. We had all these other ideas about how to deploy code, but it all required rewriting. Now you got to do microservices, which Docker doesn't make you do. You can run monoliths. You can run microservices. You can run anything you want in there as long as it runs on Linux. And they just, most of the projects I work on, we never have to touch the code. We rarely ever have to change it.
Yeah, I can see that. Amazing. All right, then. Okay, so that's a good intro to the topic of DevOps and containers.
Yeah.
That clarifies a lot of things. Now, in the terms of developers trying to, or developers knowing about DevOps, or trying to get in the field of DevOps. Is this something that every developer should know about? How do you see this? Because I understand that you're you're pro DevOps, let's put it that way, pro containers. I don't see who would be against it, but the point is this something that every developer should be aware of and should practice? Is this something that only backend developers should worry about? Is this something that a specific type of developer, or is this even something that developers shouldn't be worried about because there is someone else who's specifically there to worry about this? How is that handled?
Yeah, so it's a great question. It requires a little bit of defining of things before we can get to a specific answer.
Okay.
It's one of those things where, like, the consultant answer is, it depends. Unfortunately, the word DevOps has now been overloaded. And like a lot of other industry terms, we throw cloud around now like it should be the internet, but we use the word cloud as if it's something magic. It's just someone else's server on the internet, right?
Yes.
But we say cloud all the time. And random people on the street are like, what is the cloud, right? It's just computers on the internet. It always was. It never really changed. We just got better at delivering products through servers on the cloud. And at some point, everyone just called it the cloud. Anyway, so DevOps is the same way, where weirdly, if you try to make a parallel to what DevOps is, you could say that Agile, that we were all learning about for software development project management, we were all learning about that in the 2000s and the 2010s, but no one has a title called Agile Developer, right? It was just a way that we take a business and take a group of people that are considered engineers for software, and we need to organize the way we make changes and the way we project plan and the way that we release software. And we can all, at most people nowadays at least know the foundations of what Agile development is. And some companies actually send you through proper training and make sure that there's all these certifications. But DevOps is very much the same way, where it should have never been a title. It should have never been a role. It was simply a culture and process shift. But because tool vendors love to sell tools and companies love to sell their products saying we're the DevOps tool of blah, 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 or we're the DevOps friendly, blah, blah, blah. Well, when DevOps was coined, obviously none of that stuff existed, right? We didn't have anything labeled DevOps. So we needed, the industry sort of needed to grow up. But along the way, we kind of ruined the term. So if you want to talk about the original definition of DevOps, which was a couple of things around making sure that you have cross learning across the devs and the operations, and you're always collaborating, always learning from each other and improving two different things: velocity of software deployments and stability of your server or of your product that you're delivering your customer. So you got to be improving the velocity and you got to be improving the stability. If you're doing that using metrics, using actual data, and there's something called DORA, we can get into that, DORA and SPACE framework and all these different ways to collect metrics from your team and from your systems to make sure that you're doing the right thing for the business. That was originally what DevOps was.
Right.
And I still think today that every developer and every operator and anyone in that pipeline of changing software, the software lifecycle, would benefit from that very formal, what could be very formal training and understanding of the processes, the concepts, things like pull requests, which we now talk about in GitHub and GitLab. They have this idea of pull requests. Well, that's a part of the common vernacular nowadays for what you do in a DevOps organization. But unfortunately, a lot of us get bogged down with tooling. So someone might tell you, well, in order to learn DevOps, you need to learn Docker and you need to learn Jenkins and CI/CD and you need to learn continuous deployment, and not really. It really depends on your job roles. So I have worked with teams all over the world, and I can tell you that no two DevOps engineers do the same thing. There are a wide range of roles and responsibilities, everything from ensuring that your build environments for automating the building of your software and the testing of your software. There might be someone who's very focused on that and making sure it's fast and it's efficient and that it properly notifies everyone when there's a failure. And that could easily be someone's full-time job or three people's full-time jobs. And they might even get the label of DevOps engineer, but that's really their role. Their job is really just working on the build environments or the continuous integration and testing environments. So it gets a little complicated in the real world, because you might even see a DevOps engineer that really their day-to-day is managing Kubernetes.
Yeah, exactly.
Or managing Docker. And that's, a tool that is used in order to achieve DevOps practices, but I wouldn't necessarily label that person as like a member of the DevOps team. Regardless of all that, teams nowadays have organized themselves into, some companies have a DevOps team.
Yeah.
Some companies don't have a DevOps team, but they have maybe a DevOps individual, or they're labeled with a DevOps role or title, and they might be one or two per team. And then some companies have something that they call like a DevOps guild, where different members with different strengths, some in security, some in operations, some in development, some in build and test, some in QA, and they all come together in sort of a they're not working on the same team, but they all come together and learn from each other and try to help each other improve the business through increasing the velocity of software deployments and increasing the stability of their infrastructure. And so if they're working on that, then they are working in the DevOps space.
Right.
So the challenge is what role are you, right? If you're a developer today, are you working at all on infrastructure? Are you touching any infrastructure? You maybe you're lucky and you don't have to. You can just write software and it's someone else's job to deal with the infrastructure. But I would imagine that every developer, anyone who's involved with the software lifecycle, would just like we all had to learn agile practices in order to benefit the organization and improve the software lifecycle, we all probably need to learn some of the DevOps foundations to improve how fast we deploy, how we deploy, because that's become a relatively consistent standard for how we consistently deploy software. How do we recover from failures? How long does it take to go from a code commit to production deployment? All these things are metrics in the DevOps world. And so we have acronyms and terms for them, but at the end of the day, it's all about measuring the performance of software deployments and stability and uptime, and asking the question, are we getting better as an organization in delivering value to our customers through software, or are we getting worse? And honestly, with a lot of teams, that's hard to know. They are not capturing enough data to really answer the question, are we getting more stable in our software deployments? Are we able to recover from failure faster? Are we actually shipping more features to the customers quicker? Or, and these are all things that really are just metrics in the DevOps world. So I think everyone really benefits from that. And the one thing I'll say, if there's a couple of action items for people, if this is all sounding very overwhelming and new to you, no worries. Lots of people are still learning DevOps. Everyone coming out of university still has to learn DevOps. And there's a couple of books. The best one I think to get started with is the DevOps Handbook. It's actually written by Gene Kim and a whole bunch of other people. They just released their second edition a couple years ago. It is basically the tomb of knowledge for the concepts, the culture, and the processes that you want to implement in your company or organization for achieving DevOps goals. And it's called the DevOps Handbook, second edition. And then if you're more into the novel side of the fictional story, that thing we mentioned earlier was the Phoenix Project. There's two books. There's Phoenix Project and Unicorn Project. Yeah. And the Unicorn Project came later. The Phoenix Project was the original one from 2013. And that tries to teach you a little bit of the DevOps concepts through a fictional story like that. So it just depends on what you like to read. If you want to read something that's a little bit more of a manual and procedural DevOps handbook, if you're more about the fictional novel with people arguing in boardrooms or whatever, that's more of the Phoenix Project. So those are really the basics that there's lots of other books that try to spin it and make it fancy today. I think they're largely all just derivatives based on these a few original books. If you're into courses and you want to learn some of the practicals, the first thing I would have you do is not learn the tools. Again, you can learn 1,000 CI/CD tools. You can learn, which there probably are 1,000 of them. Yeah. You can learn Docker and Kubernetes later. But all those things rest on understanding the principles first. And one of the best courses is actually not a fresh course. It's actually, I think, made from 2016. It's on LinkedIn Learning, and it's called DevOps Foundations. I'll make sure you get all the links to all this stuff so you can send it out with the podcast. Yeah. But yeah, DevOps Foundations is it starts off with great production of two gentlemen just talking to you about the goals and culture of a DevOps practice. And they don't get into tooling or even how those tools relate to solving these problems until later on in the course, because those are things that you will continually be changing throughout your career. Everybody's waiting for the next Docker thing or the next thing to replace Kubernetes or whatever, because Kubernetes just celebrated its 10-year anniversary. So everybody's looking for the next thing. Or, is it going to be serverless? Is it, is it going to be something else? And these things are all going to change, but the principles are really staying the same, that we're really all just trying to ship software faster, easier, and then make sure that if we do have failures, that they're less frequent and that we're recovering from them faster. And so when you start to look at containers, they help with all of those goals. They help you, whether it's Docker or Kubernetes or something else, they're really there to help you achieve those DevOps goals faster. They will not say, or they might try to say they're DevOps tools, but they're not. They're just server infrastructure tooling that helps developers package up their software as an artifact, ship it up to servers, and then get it down to production and run it reliably and consistently. Yeah, that's a very long answer to that question.
that very detailed. So two things. One is you're essentially blowing my mind in the sense that there is no DevOps then. It's just a practice. Like you said, if you're looking into, if you're worried about stability and if you're doing something about stability and deployment, then you're doing DevOps. But it doesn't mean you're the DevOps guy or that your role is that, but rather you're essentially adding into the practice of DevOps. That's a different way to look at it. And the fact that you're recommending a course that is from 2016 and is still valid, that says a lot about how there is a huge split between the tools that you use and the actual practice of DevOps. Because to me, the way I was looking at this is, what is he going to recommend, especially when you started talking about books, because books get outdated really fast when technology moves forward. So what is he going to recommend in terms of books that is still valid, that hasn't been replaced 6 months ago? So the fact that you can recommend books, you can recommend courses that are quote unquote so old, in tech years at least, it's an eye opener, at least to me, in the fact that you can learn DevOps, you can learn about the whole process and practices without worrying about tech first, and then eventually like pick up whatever you need. But and in terms of tools, in terms of picking up whatever you need, are there like specific or industry standards other than Docker, or is Docker an industry standard, or am I just biased based on what I've been reading online?
Well, so Docker and Kubernetes are related projects. Kubernetes actually was launched at a DockerCon 10 years ago as a way to run Docker on many machines and then control all those machines from one CLI. Okay. So Docker itself runs as an engine or a daemon on any Linux system, and it technically can run on Windows because there is such a thing as Windows containers, but we'll leave that out of this discussion for now. And so Docker is really just about running your code in a reliable way consistently with the dependencies that you meant for it, right? And then Kubernetes said, well, nobody has just one server. What if you have 1,000 servers or 10 servers? You don't want to have to run the Docker command 10 times on 10 servers. So they created an API, and that's really their claim to fame, is they created a what is essentially almost like a data center API. We just call it the Kubernetes API, that allows you these very consistent resource or object types for how to describe the parts of your app. And then how do they all relate? How does the database relate to the back end? How does it relate to the front end? Is there a proxy involved? Do I have worker jobs? Do I need different types of storage solutions? Like, you can quantify all that now in YAML and then launch it up on any cloud that supports Kubernetes, which they all do, or on your own Kubernetes, and that allows you to run Docker containers on a fleet of servers. Now, a lot of companies don't even have to bother with Docker or Kubernetes because they can just write a Docker file for their app, and then the cloud will build it, right? You can use GitHub Actions. You can use any CI in the world that they all support building containers. And you can build the containers in the cloud, ship it to a registry, which all the clouds now have one, so you don't even need to really go get your own or make your own. And then, I think it's on AWS, they have literally dozens of ways to run containers, and only a few of those ways include Kubernetes. They have things like AWS App Runner, which allows you to run a container or lots of containers with just by describing the app in a web interface without ever having to know Kubernetes. Google has a similar thing where it's called Google Cloud Run, which allows you to run containers without having to know Kubernetes. If you like Kubernetes and you want to describe your application and all of its parts in Kubernetes YAML or in something called Helm, which is a templating system for Kubernetes, you can do that, but you don't have to.
Right.
And it doesn't mean that you're not doing the best DevOps if you're not doing this. I believe that really every modern software team, in most cases, should be deploying as containers, because the container object, that artifact that we talk about, that's still the most consistent way we know how to run your app the same way on every system, where every developer, every QA person, every support technician, every server type, every cloud type, every Linux distribution, they all run it the same way. So it's still, I think, the best thing we've come up with for building and deploying your artifact, essentially, which is your code. How you run that is really a question of the size of your team. How, do you have the technical expertise to run a Kubernetes cluster? A lot of teams don't. Yep. And I actually call a group of these people the solo DevOps engineers, where you might be saddled as the only person that touches the infrastructure in your team. Yep. And it somehow is your responsibility to build that infrastructure. Maybe you're using something in like AWS CloudFormation, or maybe you're using a popular tool like Terraform, and you can then write all the Terraform language to describe your cloud servers and the S3 buckets and the networking and the security and all the things you need. And you can describe all that and deploy it reliably with Terraform. And then maybe you're designing the Kubernetes clusters on top of that. But that's really not required. You can technically be a DevOps-focused engineer that's trying to adhere to all these guidelines and principles of DevOps, but you're using Heroku and you're not even using containers, and you're just using Heroku deploy, which is super easy to do if your app fits in that model. There's lots of competitors to Heroku nowadays. So it's not even that containers are required or expected, but I would definitely say that the norm is moving to a container solution as an object or as a artifact store, and then finding either a cloud or a data center solution that you need that can deploy and run those containers, whether it's Docker Swarm or Nomad or Kubernetes or just pure Docker. And there's even little one-off companies, like one's called Cycle, and Cycle has their own proprietary orchestration for managing all their servers. You just tell them to run containers and tell them where the container image lives, and then tell them, things like what ports and does it have persistent data, those kind of things. And then they handle everything else. Okay. And you never knew what they're doing underneath. You don't know what Linux distribution they're running. You don't know whether they're running Kubernetes or not. And that's the point. They're just trying to make it super easy, kind of like companies like Heroku or others have done. So it's not so much that you're choosing the right tools or the wrong tools. I'm always a big proponent of, if you know a tool and it serves you and meets the business goals, keep doing it. Just make sure that there's two kind of goals there when you're in that DevOps mindset. You're always trying to automate things to reduce toil. And toil is a word that we maybe don't use a lot in software design, but toil is when you're doing something over and over and over again. And in DevOps and SRE worlds, we're really trying to reduce the amount of things we do manually as humans over and over again. It's also quite boring. Yeah. So that's called toil. And one of the goals is you're always reducing that through automation. And quickly, the other one is technical debt. So one of the stories that's told in the Phoenix project is around, and we've probably all experienced this in our careers, you're in a team that's super focused on delivering customer features and not so concerned with making sure that the systems that run these features for your company and your clients are stable and that are getting better, and they're improving in reliability, and they're getting faster, and so that's something that is typically called technical debt, where you might identify, hey, actually, I've noticed we've got 3 production servers, and one of them is slightly different than the others because it's got different updates or whatever, right? So maybe you go into your Jira ticketing system or whatever, and you write down a note of, someday we should fix that.
Eventually, yeah.
Right, that's right. So that's known as technical debt, and it's not necessarily a new term to developers, but in the infrastructure world, it can be just as deadly to the software overall as technical debt inside of your developing systems, where maybe in a developer world, they might say, well, this little thing is less efficient, so it uses more, or the library we're using is getting old, so we need to replace it with an updated one because that one's now deprecated. That's technical debt. But on the infrastructure side, you could easily have scenarios where our storage isn't meeting our speed metrics for returning API calls. So that, and you put that on the to-do list. That's technical debt. We're still deploying through old shell scripts rather than using more efficient modern approaches like GitOps, which we can talk about, or something like that. So those are all things that end up as technical debt. And if your teams don't have a culture of giving just as much importance to the technical debt parts as they do to the customer feature requests, if those two things don't have as equal of representation in management eyes, then you now have a problem in the DevOps community of that organization, because you're now prioritizing customer request over stability, security, reliability, and that eventually will catch up with you. And so in DevOps, we now know that as technical debt and toil, and those things need to be first-class citizens, just like customer feature requests. In fact, they are essentially a customer feature request. If you don't fix them, eventually they will become a feature request from a customer is make this faster, or make this more stable, or stop getting hacked, or those are going to be the requests you get. And so DevOps just knows that has to be front and center as a part of your culture. And a lot of teams, it's not a part of the culture. The management does not care about that. They care about customers more than they care about the system. And we've all seen horror stories of hacks and denial of service attacks and all these things that happen a lot of times that can be avoided through, addressing the technical debt and the toil. So
interesting. And okay, and how do you? So you said that clearly this has to be important for the organization. This has to be a priority, not just the software development part, the features, as you said. DevOps itself has to be important. How do you get a company and organization to understand that, to see the value in DevOps to the point where they see and they turn around and say, okay, we have just these two guys who are running Docker and we labeled as DevOps, and we're just doing it all wrong. And we need to change everything that we believe about DevOps and actually implement it correctly. How do you go about that?
Yeah, that's a great question. And I'm just going to plug the DevOps handbook because it talks a lot about that. It talks about strategies around that you do need, like any cultural change in an organization, you need a management champion, right? You need that person as high up the chain of management that you can find that is willing to go out and sort of fight the good fight,
right,
to make sure that this type of culture change is considered and it's valuable, and that they're not just waiting for you to fail, right? Because if we've all been in that situation where we want to make a change in an organization at any level, and there might be people that are not excited about that change, right?
Yeah.
Because they like the way it is. And
correct.
If that's everyone but you, and you're just an engineer that is, not really running the show, and you don't really have a lot of authority, then it's going to be very hard for you, right? The best you can do at that point is to do what I would call sort of a skunk work project, where you try to get something into containers, you try to automate the deployments, and you need to find a developer friend that's writing the software to work with you, and then you bring the results to management, and you're going to have to collect some metrics. These are the DORA metrics that we talked about earlier, DORA. And you can maybe have some of that data and show management to prove to them, hey, look, we tried this new way of deploying software or deploying infrastructure, and it did take some work, but look at the improvements in showing we're faster now. We can deploy easier, or we have less failures, or we can recover from a failure faster because we have automatic recovery, or whatever the reason is, right? Mm-hmm. And a lot of times when I'm starting a project with a company, this is a common problem, because one person will hire me, and I'm just one individual, right? I don't come in with a team of 5 consultants. It's just me. And I'll come in, and the person who hired me is usually the fan, hence they spent the money to bring me in. But they may not be the complete decision maker of all these things. And there's always detractors when I work in an environment where they don't have the DevOps culture. There's always people there that don't believe in what I'm doing and think that the way they're doing it is just fine.
Right.
And so I will always try to find those that are willing to take a risk, that are, and it's quite honestly, it's sometimes the young people, right? It's the junior engineers that are in their 20s that are excited about all this stuff and want to play with new tools. And maybe the people that are more my age, 40s and 50s, are less interested in it because they feel like the way they've been doing it for 20 years is just fine.
Right.
And that's okay. So you're going to find those people. You're going to hopefully find someone in management that will give you the permission to at least try it without basically blaming you for any failures, because you might not get it right the first time. And I would go after pain points. The thing that I always focus on when I'm working with a team on, they want to implement Docker, great. I don't really care that this is the tool we're going to try. I want us to focus on a major pain point for the team. So the first meeting we ever have, I have everyone in the room, in the Zoom or whatever. I have them write down their top 3 or top 5 or whatever pain points of doing their job every day.
Right.
And of course, none of them are going to put in there, I don't like my boss, right?
Yeah.
Because it is public. So
you're not going to fix that either. So.
Right. That's right. They're going to put in things like, by the time I make a commit to deploy the software, I make an update to the software repository, and then it takes me 2 weeks in order to even get that into schedule for production deployment, right, or whatever. Or our jobs in our CI solution keep failing, and I don't have the permissions to fix them. So then I need to go find someone else to go and access it and troubleshoot and then fix it and then tell me, right? So all these things start coming out, and sometimes it's very ugly because it's just so much broken stuff, which leads us back to the technical debt and the toil.
Yeah.
A lot of this stuff comes from that. So we will focus our efforts on what is the biggest complaint of the team overall. Like, what is the consistency here? Is it deployment time? Is it failed, CI testing jobs that aren't reliable and keep failing even though they technically worked, right? So we'll start addressing those things. And what's funny is the teams will sometimes come to me and say, well, we hired you to deploy Docker. And I would say, well, but before we do that, what's Docker on your servers if you can only actually deploy the software once every 2 months, right? If you have this long testing cycle and this long QA process, Docker can't help you on the server really because it's not getting touched but once every 2 months. So what's the difference? Docker and Kubernetes really excel when you want to deploy as frequently as you're able to deploy. If you can do it daily or hourly, Docker and Kubernetes are meant for that, right? They will help you do that and make it so easy to replace that software in real time with zero downtime deployments. But if you can't even test it or build it once a week, then why bother? So a lot of times we will end up shifting the project, focusing more on automating things, improving reliability of things, and then eventually we'll start to try Docker and implement that. And to plug, I'm going to stop for questions, but to plug a almost 15-year-old manifesto, the 12-factor app, we'll include this in the links, but the 12-factor app, it's actually just 12factor.net, 12factor.net. This was a document. It's very short. You can read this in an hour. It's just words. But it was written by Heroku back in like the early days of DevOps, 2008, 2009. And it was listing 12 things that determine the success of a distributed application and a team that's running distributed apps. And news, folks, everybody's running distributed apps now. Like everything we do is distributed. And they're very basic. They're things like concepts around making sure that your environment settings aren't hard-coded in your app. So if I take your app and I run it on Microsoft's cloud versus Google Cloud versus my own machine, the only thing I should have to change are environment variables.
Right.
Or and maybe a config file if that's what's required. But I should never have to change code, or I should never need a different branch of the code for that. And so that's just one of the 12, right? And so when you start looking at these 12, you realize that the DevOps world and the Docker world and the Kubernetes world were all based on these 12 ideals. And most apps that have a hard time migrating to a DevOps world and being fast and agile in their deployments and recovery.
12 points.
Yeah. What's that?
Yeah, they're not following those 12 points.
Yeah, that turns out that they're actually not following those. Exactly. And that means that we have to go back to basics, and we actually have to start talking in the team about what does it mean to have your app so that it can be testable from anywhere, so that I don't have to wait on a server in a Magic Data Center, that I can actually test the code locally, which a lot of developers can't do. Mm-hmm. And that's not really a tool-specific solution. Yes. That's just sort of an ideal, that if we can come to that and have the team approach that, then that helps everyone. And that helps our ability to test faster and more often and be able to test smaller changes. So yeah, it's funny that a lot of this stuff is really 15 years later, we're still just trying to implement the ideals that, the builders of the cloud made, basically.
Isn't that a bit frustrating? You've been at it for so long, and it's like the industry hasn't really understood the concept yet, clearly, because if you're still hammering 15-year-old concepts to new dev teams, then clearly there is a gap there somewhere where developers are coming from that we're just not teaching that. We're just ignoring that and hoping that eventually they figure it out. And they figure it out thanks to people like you.
That is true. It is. I wouldn't say it's frustrating for me now. Again, like since I've been doing this since the early 90s, I would say that this is normal. If you talk to a retired programmer from like the 70s, right? Like if someone who was doing COBOL and mainframes, they will tell you that most of the ideas we're all talking about at conferences that we're super excited about, they were talking about in the 70s.
Right.
The challenge in the industry is because we're not formalized, right? We're not like plumbers or utility builders,
True.
right? We don't have code or rules that we'll get in trouble with the law if we don't follow, right? We're just now, as a society of engineers, slowly getting to that where, like, finally the U.S. implemented some at least basic standards and repercussions for security, but it's still very nebulous and hard to figure out what to do. That was just a few years ago. But as a whole, we're just repeating, rinse, repeat the same ideas decade after decade after decade because we're not great at passing knowledge on. I think there was a great older, maybe in his 60s or 70s individual on Twitter a couple years ago that was coming out of that came home from a conference and basically ranted on Twitter for a few minutes and said, there's nothing new at these conferences that we weren't doing in the 80s and 90s. All these ideas are just rehashing old ideas. And it's clear to me now, I think, and this is in their voice, it's clear to me now that we're stuck in a rut where we don't know new ideas because we're not able to pass on all the knowledge. And so much of it's being lost that the new people, the young people, are relearning them on their own and then shouting from the rooftops as if it's new. We don't really have a way to figure out how do we fix this cycle of relearning the same lessons over and over again, and nobody's really figured it out yet, right? So we don't have a single international unified body that codifies these things in the rules and regulations that we can all have to know before we can even write software on day one. In a certain way, it's wonderful and it's freeing, and anyone can write software, and your 7-year-old can write software, and your 70-year-old can write software. But at the same time, it creates the world that we're sort of living in, where a lot of software kind of sucks.
Interesting. That's a topic for another episode. Definitely. For sure. All right. Okay. That's it. Last question I'm gonna ask you is: you've been at it for so long, and we just touched on this. This is not new. The same concepts have been repeated over and over and over, but I want to believe that there is some advancement being done. I want to believe that evolution is happening at some stage anyway. So where do you see DevOps? Where do you see this, or at least the technology side of DevOps? I don't know. I'll let you decide how to answer the question. Where do you see this going in the future, in the next 5-10 years?
Well, what Docker and Kubernetes did for us was it standardized the deployment object, and it standardized, and I'm going to talk about GitOps for a second, because that's about 5 years old now, so it's not terribly new.
Okay.
But GitOps, on top of those containers, although it's not exclusive to containers, GitOps is a horrible name. It doesn't actually mean you're using Git.
Okay,
usually
thank you.
Because, nowadays we all use Git. Mercurial and SVN and Team Foundation Server and all these other things that we've used in the past are largely replaced with Git. So the term GitOps came about as a standard methodology for deploying or updating or redeploying or recovering from failed deployments to our infrastructure. And we didn't really have that. Even though Docker had standardized the deployment artifact, we had Kubernetes as a standard that's now, I think it's something like 99 or 100% of the Fortune 500 are all using Kubernetes in some capacity. And I mean, it's saturated the market, right? So it doesn't mean that everyone has to run their own, because there's plenty of ways to run it without ever even touching it or knowing anything about it. But what it did was it standardized the ideas around infrastructure so that we knew what things like a replica is. You might have 2 replicas of your website container. And those were concepts that even just a decade ago, you wouldn't hear us talking about, right? You and I would have to describe or agree upon what a deployment object is. Are we deploying a VM? Are we deploying to Heroku, which doesn't need it? Like, we just had all these different things. So the nice thing is we've at least standardized parts of the infrastructure like that. And the next phase is standardizing the deployment. Whereas maybe, even just 5-10 years ago, you might deploy through a shell script. I might deploy through Ansible and writing my own code in Ansible or shell scripts. Someone else might be using Chef, which has a completely different mechanism. Someone else might be using CloudFormation or some other tool or some AWS-specific tool that's only good on AWS. And the idea of GitOps was the idea that we could store the configuration and the way that our app's supposed to work together and the way it's supposed to be deployed, we can store all that in change management, hence Git, and that we can track the changes to how we deploy and when we deploy things in Git, and that the infrastructure would understand how to get those changes out of Git. So there's actually a great website, we'll also put that in there, called Open GitOps, which is the industry coming together on how we should deploy software in an ideal world where everything understands and supports this GitOps idea. And it's not a tool, it's just it's a utopia. It's kind of like DevOps. It's just an idea for a set of processes and culture around how to deploy your software and then to deploy it 1,000 times a day.
Right.
On 20 different environments, with whether it's containers or not containers. And a lot of tools now have started to pick that up, and they will say, like, we're GitOps friendly deployment tools, or and there's one called Argo, and there's one called Flux, and other ones are appearing all the time. CI tools are now saying we support GitOps as a deployment methodology. And so this world of open GitOps, which is the sort of the non-vendor specific version of what GitOps means, it really has 4 sets of principles. I won't read them to you. You can go learn about them at the Open GitOps website. But that is becoming a standard now, so that we can at least stop rewriting the same things over and over again because you think you know better how to deploy something than I do. Right? So then you make your own tool. That's the problem with us developers. We love to make new tools. And so developers have figured out their own languages and their own frameworks to standardize for decades now. And infrastructure people are still struggling because we've at least standardized on using something like Terraform, but that's a specific tool. So what happens when Terraform's no longer used? Now we have to rewrite everything. And so at least Docker is using standards now called OCI standards, so that you don't have to use Docker. All the different container tools can all run the same containers. Doesn't matter whether you run Containerd or Docker or Cryo or Podman or there's a whole bunch of them. Okay. And they're standards now. Kubernetes can now standardize on all those things. And the next wave, I think, is that deployment, and that's known as GitOps. So once you've kind of learned containers, once you started to dabble around with Kubernetes, then go check out GitOps, because that will help you standardize how you deploy your software. And then when you hire that next engineer, and this is the real goal, right? Because we're all moving jobs faster than ever. Back in my day when I started, you stayed at the same job for a decade or 5 years. Now people are at jobs 1 or 2 years at most. And so the problem with that is every time you bring in a new engineer, you've got to teach them everything brand new, right? This is how we do our local development environment setup, which is completely different than every other organization. Well, Docker's helped improve that so that it's not completely different. I love Docker Compose for that. It's very consistent, and most of my clients use it. Right. And then we now have the infrastructure standards, so that when you hire a new engineer, you don't have to say, we've made our own completely different infrastructure design based on our own expertise, and we use Salt Stack with shell scripts and blah, 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 right? We can now start to say we've standardized as containers as our deployment object, and we're now using it in various ways, including Kubernetes. And now we're getting to how we deploy it. And you can even look into something called Open Telemetry for how we monitor, which is now become an industry standard called Open Telemetry for how we monitor, log, and use tracing inside of our applications. And once you standardize on that, you now can move platforms or hire new individuals, and that you didn't completely create your own custom monitoring stack and metric stack. So I think a lot of these things around during the deployment and then after deployment, where you're monitoring and using APM for performance monitoring, like those areas are all getting standardized as well. The one organization you can follow on this is the CNCF, the Cloud Native Computing Foundation, which I'm an ambassador for, which entails Docker and Kubernetes and thousands of member organizations. The CNCF is creating all these standards so that all these different tools can interoperate. Everything from the commit on your local machine all the way through to production deployments, backups, and monitoring and recovery. So check out CNCF. and look for tools that are in that ecosystem, because those are the tools that are trying to standardize on a set of principles, all centered around DevOps and containers and GitOps.
Fantastic. So essentially, if I understood you correctly, you see the future of this as in the standardization of all these processes and all these tools,
right?
So that eventually we can just shift or just change or move when the technology is irrelevant. They're all doing essentially the same thing underneath.
Right. Pick your own tools, but if we're all developing with a consistent environment style, we're probably developing in containers or maybe locally, but if it's always packaged up as containers, and the idea is that you might decide to switch from Node.js to Go, but that doesn't mean you completely switch everything about how you develop, right? And so for infrastructure, we're trying to do the same thing, where at least all these tools that we have so many tools now. We are in tool bloat. We have so many tools. We're in the best years of tools out there with open source. And the problem is there's no standards. So they all behave completely different. They all have their own opinions, which are sometimes good opinions.
Yeah.
But they're not compatible. And so we're all trying to create this compatibility underlayer so that you can decide that you like this tool. You like to deploy with the Flux tool, and you like this version of this distribution of Kubernetes. Maybe you like Ubuntu's version of Kubernetes, or maybe you like AWS's version. It doesn't really matter. If there's standards behind it, all these tools will interoperate, and you can get back to the business of writing and deploying customer feature requests instead of worrying about how your infrastructure works versus the other team. I've been in plenty of companies where they're big enough with dozens, if not hundreds, of engineers that each team has their own implementation of infrastructure that's completely incompatible with the other teams that are next to them in the organization. And so we're really trying to get all this standardized so your tools can interoperate, and those teams can still choose their own editors for coding, and their own tools for testing, and their own version of Kubernetes, or the own way to use containers. But at the underlying layers, all interoperate, so it doesn't really matter. It just all works together. So, yeah.
Understood. Fantastic. All right, that's it. Thank you, Bret. Thank you so much.
Thanks so much.
It was an incredible learning experience for me, and hopefully for everyone else listening. But I got to actually understand DevOps. So, the episode is great for me. So I love it. That's it. We'll add, obviously, all the links that you've mentioned to everything in the show notes, so everyone can look into that. So just one last thing: how can people reach out to you? How can people find you online?
Yeah, so you can find most of my stuff at bretfisher.com. That's BRET, 1T, Fisher, FISHER. I'm on all the things. You can find me on YouTube. We go live every Thursday. You can join us live. We're learning new DevOps tools, new people in the industry that are coming in with ideas right now. Obviously, we're talking about AI and everything. And you can get coupons for all my courses on my Docker and Kubernetes and other things. You can just get all that on my website, or just look me up on Twitter, YouTube, LinkedIn, you name it.
Everywhere. All right.
Yeah.
Awesome. Again, thank you so much, Bret. It was amazing. And that's it, folks. Thank you for listening, and I'll catch you in the next one.
Glad to be here.
Yeah.
See you next time.
You too. Bye. And that was it for this episode of the Scripting Them podcast. Thank you so much for listening. Remember that you can find me online on Twitter at TheDeepMan123, and you can also find the podcast YouTube channel just searching for the Scripting Them on YouTube. Thank you again, and catch you on the next one.